In this screencast, I present another proof of the theorem that every natural number has at least one prime factor. So to state the theorem, every natural number greater than 1 is divisible by some prime number. To start with, we're going to consider a number n, which is a natural number. If n is prime, then it is its own prime factor, and so we are done. But if n is not prime, then it must have some factors which are greater than 1 and less than itself. So what we are going to do is to let S be the set of all the factors of n that are greater than 1. Our next step is going to be assume that none of these factors are prime. If we can contradict this, then we have shown that every natural number must have a prime factor. So, we look at the elements of S. We now use the well-ordering principle. If our set S is non-empty, and it is a set of natural numbers, then it must have a least element. So we let n0 be an element of S, and n0 is greater than 1, because all the elements of S are greater than 1. We let this be the least element of S, that is, the smallest element. Now we look at this element of our set. We have assumed that none of the elements in our set are prime. That is, we assumed that none of the factors of n, which are greater than 1, are prime. So if n0, the least element, is not prime, because none of the elements are prime, that means that there exists an ni that divides n0. Ni must be bigger than 1 and less than n0. Now, because ni is a factor of n0, it is clearly also a factor of n. But this implies that ni actually lies in our set S, because it is a factor of n and it is greater than 1. Therefore, we've shown that if n0 is not prime, then n0 is not the least element. What this indicates to us is a contradiction. By having shown that if n0 is not prime, it is not the least element, it is clear that our assumption that the factors of n are all not prime must be wrong. The least element must be prime, and perhaps some others as well. As such, we've proved that every natural number n must have at least one prime factor.